Alright, in this tutorial we're going to talk about 2D arrays, and what you need to know about 2D arrays is that they're just another data structure. They're actually similar to 1D arrays in a lot of ways. They have indices, in this case we're going to have 2. They're static, meaning that they can't grow or shrink as needed, and they're also contiguous in memory, meaning that they're side by side. So essentially all that we're doing is adding another dimension. And we're actually going to be using these data structures to hold our 2D terrain. Whenever we need to traverse a 2D array, typically we use a nested loop. So we can do things like finding the min and the max and the sum and the average of all of the elements inside the 2D array, or we could even print out each element. To create a 2D array, they always follow a format. In this case, I've created a 2D array called grid that's actually a 4x4 set of integers. They'll always follow this format though, where we have data type and then a pair of brackets, and on the inside of those brackets we have a comma, meaning multiple dimensions, followed by a name, the assignment operator, and then new data type, whatever we want, and then we specify the width and the height in the brackets. So in this case I've actually created a 4x4 set of integers, and so therefore you can see the width and the height of this 2D array are 4x4. So the question is, how do we initialize this array? Well, by default everything is initialized to zeros for us, but what if we wanted to initialize each cell according to its index? Well, we might do something like this, where we have an outer loop where y goes from 0 up to but not including 4, and then we would have an inner loop that goes from 0 up to but not including 4 as well. Notice that we've reversed the order in which x and y appear. A lot of times people want to put the x on the outer loop and the y on the inner loop, but that's not necessarily how we're going to do it. And this is actually going to be architecture dependent and language dependent, because sometimes 2D arrays are column ordered versus row ordered. So to start off, you can see that x and y are both 0. So when we go inside this nested loop, you can see that we're going to multiply x times y, which is going to give us a 0, and we're going to put it into this particular location. The next thing that happens is x is incremented, so x is now 1, and you can see that it's moved over. And again, what we're going to do is to multiply x times y and put it into this particular slot. In this case, it's 1 over 0 down. Again, we increment x, so x is now 2. We come back inside, we multiply 0 times 2, and that gives us a 0, and we put it into this particular slot. We'll increment x again, and now x is 3. 3 times 0 is going to give us 0. And we go back out to the loop again, and you can see that x is now going to be 4. And in this case, 4 is not less than 4, so this returns a false. So at this point, we can now go to the outer loop, and we can increment y. Well, because 1 is less than 4, we need to come back inside this loop. The outer loop is still executing, and we're going to reset x to be 0. So at this point, x is 0 and y is 1. So on the inside of this loop, you can now see that 0 times 1 is still 0. We're going to increment x again, and now you can see that we have 1 and 1. And in this case, we have 1 times 1, and we're going to put it into slot 1, 1. We increment x again, now we have x is 2 and y is 1. So 2 times 1 is 2, and we'll put that into slot 2, 1. We increment x again, and you can see that we're going to put 3 into this slot. We're going to increment x again, causing the inner loop to fail, and then we'll go back to the outer loop and increment y again. So I think you can start to see the pattern here. We're going to iterate through each row, hitting each cell in that row and assigning it some kind of value. We can do the same thing for this last row and see how the nested loop terminates. So you can see that we have 3 and 6, and in the last case here we have 3 times 3 is going to give us 9. We do one more x plus plus, and you can see that 4 is not less than 4, so the inner loop fails, and then that takes us to the outer loop where we do a y plus plus, and now 4 is not less than 4, so the outer loop is false. At which point we can finish this nested loop and then continue processing down here. Just like 1D arrays, there's a lot of common operations that we would want to do with 2D arrays. For example, we might want to find the smallest element inside this 2D array. So if we look at this code here, you can see that I've declared a variable called int smallest and assigned it to be grid 0, 0. It could actually be any arbitrary cell within the 2D array. Now on the inside of the loop, as we're traversing this 2D array, if the smallest thing that we've seen so far is greater than the current cell that we're looking at, then what we'll do is we'll update the smallest thing that we've seen so far based off of that current cell. Finding the sum isn't really that different either. Here you can see that I've declared a variable called int sum and set it to be equal to 0. And then on the inside of the nested loop, I'll say sum plus equals the current cell that we're looking at. If we were to try to find the average of the array, you can see there's really not that much difference. The only difference here is at the bottom where I say double average gets the sum divided by 16. And the 16 actually came from the dimensions of the 2D array, 4 by 4. So, things to note here. All of these examples had a nested loop, and you're going to find that that's generally true when working with two-dimensional arrays. It was really only the logic that had changed. So, as we're working with 2D arrays, you're going to find out that they're actually very similar to working with 1D arrays. So that's it for this tutorial. Hopefully you understand a little bit more about two-dimensional arrays and how to traverse them.